Hi guys, let's solve today's Leetcode problem, which is problem number 3121. Count the number of special characters 2. Okay, so it's a medium problem. You're given a string word. A letter C is called special if it appears both in lowercase and uppercase in word, and every lowercase occurrence of C appears before the first uppercase occurrence of C. Return the number of special letters in this word. So this is the problem where both uppercase and lowercase of that character should exist in the word, and all the occurrence of that character C should appear before the first occurrence of uppercase character. Okay, so let's see the example. So here both for A, if you see both lower and uppercase exist, so first criteria is met. Now another criteria is all the occurrence of small a, basically lowercase a, should appear the first occurrence of uppercase a. So first occurrence of uppercase a is here, and all the characters, lowercase character of a are before that, which means a is one of the special characters. So a is the count. Now for b, if we see b, small b and capital B both exist, and this b, lowercase b, exist before the first occurrence of uppercase B. Okay, so this is also special character, and similarly for C also. Okay, so for that reason answer is 3 here. And if we see this example here, the capital occurrences, basically uppercase occurrence, is not at all for these characters, so answer is 0. So basically first condition itself is not met. Now if we see this example here for A, if you see the first occurrence is of uppercase and lowercase occurrence comes after that, which means A is not a special character. Similarly for B, if we see, so this B, small case, appears before this B, uppercase appearance, but this B, lowercase one, that is after this occurrence. But the question clearly says that every lowercase occurrence of C. Okay, but this another B, that is a lowercase, that appears after the first occurrence of this uppercase B, right, which is wrong. So for that reason B is also not a uppercase. Now if we check for C, so for C, if you see, there is only the uppercase occurrence, the lowercase occurrence is not there. So for that reason answer is 0. There is no special character in this word. Constraints, if we see, it's up to 10 to the power 5, and word consists only lower and uppercase English letters. So what is the approach that we are going to cover? One is the brute force, then the optimal approach, and we are going to discuss some alternative optimal approach as well. We'll just discuss those briefly. Now let's get started. Now, if you see, what does the special character means? So there is two criteria. First is both lower and uppercase exist, and second is if every lower occurrence appear before the first occurrence of uppercase. Okay, so these are the two criteria, and first criteria is clear that both occurrence should be there, and for second one, that every lower occurrence should appear before the first occurrence. So we can say that if we know the last occurrence of the lower case and the first occurrence of uppercase, so here we have to compare with the first occurrence of uppercase, right? And for every occurrence of this lower case. So if I know the last occurrence of lower case, so last occurrence should also appear before the first occurrence of uppercase, right? So what if I just compare with the last occurrence of lowercase with the first occurrence of uppercase? So that should be before it. Okay. So if we know the last occurrence and the first occurrence of this last occurrence of lowercase and first occurrence of uppercase, then what we can do? The last occurrence of lowercase should be before the first occurrence of uppercase. Okay. If it is there, which means our character is special. So that is the core idea that we are going to apply for this solutions. Now let's check the brute force approach. So for every letter from A to Z, what we are going to do, we are going to find the last and first occurrence of lowercase and its uppercase value by scanning the entire string every time. Okay, so and we will see if it the above condition is met or not. Okay, so we have to iterate for every character from A to Z. So we'll start with A. Okay, we can have two variables saying that last occurrence of lowercase and first occurrence of uppercase. Okay, and we can initialize this as value -1, saying that it has never been seen yet. So for A, when we see this, so we can update the last occurrence to 0. Then we see another A, we can again update. Then we see the capital A. So for capital A, this is the first occurrence. Then, so since we need to store the first occurrence, we need to only update once, okay, when the first time it is seen. So since it is -1, which means it has not been seen before, so we can update this value to 2. Okay. Now, if we further iterate on the string, we will never find more occurrences, though we need to, scan through the entire string to know if there are more occurrences of this A or not. So after iterating, we got to know that this is the last occurrence of small case and this is the first occurrence of uppercase, and this value is definitely less than this first occurrence of uppercase, which means this is a special character, so we can add that into our count. Okay, so we can maintain a count variable also, which will be now 1. Similarly, we will check for next characters B, C, D up to Z. Okay, so this is the approach. Now let's check the code for this. So here we have initialized this count variable as 0 and n as word dot size. Now we are iterating on this 26 characters, the English letters that we have, and we have these two variables, last lower and first upper, initialized as -1, and then we are scanning the string to know the last and first occurrence of this character. Okay, so if this word of I is equal to this A plus CH, what is this A plus CH means that this is the lowercase character of this particular character. Okay, so if it is, then we can update, we can keep on updating the last occurrence of lowercase. Okay, otherwise if it is uppercase, okay, so this otherwise this will tell me that this is uppercase of this particular character only. Okay, for that reason we have did A plus CH, so uppercase of this particular character, and first upper is equal to -1, which means we have not seen the occurrence of this character before. Then only we need to update this because we need to know the first occurrence. So we'll update the first upper to I. Okay, and after iterating through the scanning all the words characters in the string, what we can do, we can check if the last lower value is not equal to -1, which means that lower character must exist, and first upper is not equal to -1 means the uppercase character also must exist, and this last lower should be less than last upper. If that is the case, then we can increase our count that this character ch is a special character. Okay, so we will update our count and at the end we can return the count. Now if we see the time complexity, so for every character which is from A to Z, that is of length 26, we are scanning the string every time. So time complexity is nothing but 26 into n. Okay, which is more of less, we can say that O of n in only, because 26 is more or less a constant value. So our test cases would pass for this case, but we can definitely optimize it, which we will see. And space complexity we see, so we have taken just few variables, nothing more than that. So that is the space complexity. Now let's check the optimal approach. Optimal solution is basically we will use two arrays to store the first and last occurrence of both upper and lower case characters. And once we have stored it, we will do this by scanning the string only once. Okay, I'll update the answer for all the characters at once. Now, once we have stored the answer in upper and lower case, what we will do, we'll scan through these 26 letters and check if this character is special or not using the same above condition as we were doing above. Okay, so we need to first fill these array, this whole the last lower and upper values. So when we do this, right, A, so for A I know this is 0, then again I see A, then I can update this value to 1, then I see capital A, so for capital A this value will be updated to 2. Okay, then I see small b, so this will be updated to 3, then I see small c, this will be updated to 4, then I see capital B, this will be updated to 5, capital C, this will be updated to 6. Now we have updated the first and last occurrences of these characters in the string. Now, once this is updated, we will go over and check if these values are not equal to -1, both of these values, and this lower last occurrence should be less than the first occurrence. So if we check for all of these three characters, because in this word there is only three characters that exist, so all of its last occurrence is less than the first upper occurrence. Okay, so for that reason count would be 3. Okay, and that is the answer. So same thing what we were doing above, only difference was that we are storing these occurrences beforehand just by the single pass and single scan, and we were using these to find our answer. Not, we don't need to iterate over every character and find its first and last occurrence. The only difference. Now let's check the code. So same thing, we have this n as word dot size and the count initializes 0. Then we have this array first upper and last lower. So the as initialized as of size 26 and values as -1, saying that it has not seen yet. Okay, now we are iterating on the string ones, that is scanning the string ones. The C is word of I. Now we are checking if this C is lower. Okay, so this is lower is a method in C++ through which we can know if this character is a lowercase character or not. So if this C is a lowercase character, then we can update the last lower of this index. This will give me the index C minus A. I'll update that value to the current index. If it is not lowercase, which means this is a uppercase, but if this value is uppercase and this first upper of this again index is equal to -1, because we need to store the first occurrence only. So if this case condition is met, then only we will update the first upper to of this index to I. Okay, now after doing this scanning, we would have updated all the values for these two array. Okay, this value would have been updated. Now what we can do, we can iterate on this letters, this array of size 26, and we can check if this last lower is not equal to -1, which means this lowercase exists. Last upper, uh, this should be first upper. Okay, first upper of I is not equal to -1, which means upper also exists, and this last lower is less than first upper. Okay, then we have to increase the count, same as above. Okay, so and at the end, after calculating, we can return the count. So time complexity, if we see, so this loop is going for O of n and another loop is going for 26. So it is O of n plus O of 26, which is definitely O of n only, because O of n is the larger value among these. And space complexity, if we see, so it is O of 2 times this 26 size array, right? Which I can say, let's say O of 52. So that is nothing but O of 1 only. We can call this O of 1. Okay. So this is the space and time complexity for this approach. Now let's check the other, what are the other alternative approaches that we have. These are just the alternative approaches. It will not give us much benefit, but we will just briefly discuss it. So in above we stored two array, right? So instead of storing two array, we could have also used two map data structure for storing the same and same operation as we did above. We have to do the same thing, okay? That the last occurrence of lowercase and first occurrence of uppercase, the same thing we need to know across, okay? That is the first approach that we can follow. Another is if we store the state. Okay, so this is state tracking approach. So in this case only we need one array. Okay, so if you remember, the yesterday question was this question is basically extension of yesterday's question, right? So there we solve that problem using multiple things. Same thing we can do, we can solve this using a single array, or we can solve this using, bit set as well as we did on yesterday's problem. But how we will do that using the state tracking. Okay, though this bit set would be a little complex, but we this is still doable. I'll just briefly explain. So the state transition, how, what states we can define. So we can say that if it is 0, which means this is not, value has not been seen yet. If it is 1, which means that lowercase has been seen. Okay, if it is 2, which means it is an invalid. Okay, for invalidity there can be different reasons. If it is 3, which means it is a special and a valid, which means uppercase is also seen, lowercase is also seen, and all the lowercase that we have seen so far comes before the first occurrence of uppercase. So these are the states that we can define, and similarly we can see the state transition also, that if how will state transition. Okay, so if we encounter lowercase, then this is how state will transition. If we encounter uppercase, this is how states will transition every time. So if we just see any one case, okay, so if it is 0 and if it is lowercase, so we can change the state to 1, saying that first occurrence of lowercase is there. Now let's say if I see more lowercase, okay, but it was already 1, okay, which means it will again remain 1 because there are more lowercase occurrences. Now let's say if it was 3, basically it was a special case, but now this lowercase appeared. Okay, So this was a special case, and now it is lowercase is appearing, which means that after the first occurrence of uppercase, there is another lowercase, right? Which means it is wrong. So we can change the state to true, which is invalid. So similar way we can, do the state transitions. But the thing is, there will be, lot of if else thing. But overall, if we see the time complexity, so it would be O of n only, because we will still be transitioning through all the string. I mean, we will still be scanning through all these characters in the string. And space complexity, if we see, so here we are just using a single array of size 26. Okay, and we are using different states to track that. So no two array, okay, for the same thing. But the thing is, this is very small added benefit that we are getting, right? So above approach, it was O of 52. Altogether, we are considering this as O of 1, and even this as O of 1, right? So this is very small benefit, but it comes with added complexity. Okay, lots of if else cases will be there, and this state managing thing, which is not really required for this much of, benefit that we are getting. It is not justified, and this is not a very elegant solution. Okay, so above approach that we discussed using two array, that is a very acceptable approach and very most optimal approach as well. So yeah, that's about this. I hope you understood the solutions that I explained. Thank you for watching. Stay tuned for next videos.